Hi, in this series of videos, I'll solve the free response questions to the 2023 AP Stats exam. This is my solution to problem 5. Number 5. Wildlife biologists are interested in the health of tule elk, a species of deer found in California. An important measurement of the tule elk health is their weight. The weight of a tule elk is difficult to measure in the wild. However, chest circumference, which is believed to be related to the weight of the tule elk, can easily be measured from a safe distance using a harmless laser. A study was done to investigate whether chest circumference in centimeters could be used to accurately estimate the weight in kilogram of male tule elk. For the study, wildlife biologists captured 30 male tule elk, measured their chest circumference and weight, and then released the elk. The data for the 30 male tule elk are shown in the scatter plot. We have a scatter plot with the x-axis is the chest circumference in centimeters, and the y-axis the weight in kilograms. Part A, describe the relationship between chest circumference and weight of male tule elk in context. In context, don't say X and Y, say chest circumference and weight. There's a standard way for the AP to grade how you describe the relationship of a scatter plot. Do you want the strength, like strong or weak? You want the form, linear or nonlinear? You want the direction, whether or not it's a positive relationship going up together, or it's a negative relationship where one goes up and the other goes down. And the fourth thing is whether there are any special points, such as outliers or influential points. This looked linear, positive, and it's not quite strong. And the last thing I would look for is any influential points or outliers, and I don't see anything. Therefore, I'd say it like this. There is a somewhat strong, that's the strength, positive, that's the direction, linear, that's the shape, between chest circumference and weight of tule elk, I guess male tule elk, with no apparent influential points or outliers. 4 things they're looking for, 4 things I'm giving them. Following is the equation of the least squares regression line relating chest circumference and weight for the male tule elk. Predicted weight is equal to that. And part B asks, the weight of one male tule elk with a chest circumference of 145.9 is 204.3. Using the equation of the least square regression line, calculate the predicted weight for this male tule elk. Show your work. Predicted weight of this male tule elk. Sometimes I just copy down the question. Calculate the residual for this male tule elk. Show your work. Well, this male tule elk is 204.3 kilograms, whereas we're predicted to be 196. So for this same X value of 145.9, this number here is 196.17, whereas the actual value here is 204.3. And the residual is that length. The residual will be, you take these 2 numbers and just subtract them. Well, some of you may have trouble remember which one subtracts which one. Is it 204 minus 196 and end up with a positive number, or is it 196 minus 204 and end up with a negative number? Well, the way I remember it is I treat the least square regression line like an x-axis. If I flatten it out, then it's kind of intuitive that this should be a positive and that should be a negative number. Therefore, I should take the observed number and minus the number on the line, minus the expected number. So the residual, observed minus predicted. So go to 204.3 minus 196.17 equals 8.13 kilograms. Part C, interpret the slope of the least square regression line in context. So here's the slope, and the slope in algebra means that for every extra 1 in x, that's how y value is moved. So x here is the chest circumference. Y here is the predicted weight. So every extra 1, in this case centimeters, in chest, we expect the elk or the tule elk to have 3.7 something extra kilograms in weight. Notice that I said expected. This is a predicted weight, not an actual weight. So that's the degree of uncertainty that comes with linear regression. We need to put that in the answer. Let's write it. For every extra or additional, in male tule elk chest circumference, we expect an additional 3.4755 kilograms in predicted weight. Part D, the sambar, another species of deer, is similar in size to the tule elk. The slope of the population regression line relating chest circumference and weight for all male sambars is 4.5 kilograms per centimeter. A wildlife biologist wants to determine whether the slope of the population regression line for male tule elk is different from that of male sambars. Let beta represent the slope of the population regression line for male tule elk. The wildlife biologist conducted a test of the following hypothesis using the sample of 30 tule elk. H0 is that beta is equal to 4.5, that's the slope for the sambar. And HA is that beta is not equals to 4.5. The test statistic was calculated to be 3.408. Assume all conditions for inference were met. Determine the p-value of the test. The test for the slope uses the t-statistic. If you don't remember, go look in your calculator. See where it falls under. So under Casio, it under t and then reg. So you know that it uses a t-distribution. For the TI, the name of the test is lin-reg t-test. So again, you know it uses the t-distribution. So test of slope uses t-distribution. Have a t-distribution that looks like the normal distribution. It has a test statistic of 3.408. And because this is a two-sided test, two-tailed test, then that means there is a negative 3.408 back here. And then these two together makes the p-value. If this were a normal distribution, you know how to calculate this. For the t-distribution, you use a similar process on your calculator to find this number. So p-value is equal to the probability that t is less than negative 3.408 or t greater than 3.408. You can take one of them and multiply by 2. Well, then when you plug it in on your calculator, you realize you need the degrees of freedom. And you remember that, oh, my teacher taught me that, yes, the t distribution comes with degrees of freedom, but I don't remember how it went. I know that for the mean test, degrees of freedom is n-1. Well, is this one also n-1? Well, it turns out it's not n-1, it's n-2. But if you don't remember that, I would do this trick. I would fake, let's say 5 points, x, y, and then I would run my test. So on the TI would be Lin-Reg t-test. On the Casio, it would be test t-reg, and see what the degrees of freedom is equal to. Well, you will find out that it will show df equals 3. Then you say, aha, it's not n-1, it's n-2. So that's how you remind yourself that it's the degrees of freedom is n-2. So I write down degrees of freedom is equal to n-2 equals 28. And then I run the probability. And it's equal to 2 times this, which is 0.002. I'm going to write the word t distribution down here, and also the word t here, because AP looks for defining the distribution by name or by formula, and sometimes they give you some more options. For example, sometimes they accept calculator speak. I'm just going to put t everywhere just in case. So p-value is 0.002, and then I now can write the conclusion. Sure enough, part II asks for a conclusion. Reject is not. There is convincing statistical evidence. And then I write down all of that. That's the parameter in the context. Is not 4.5. And the unit of the slope is kilogram per centimeter, but they have not been using it, so I'm not going to put it in. That's question 5. There are other solutions to the other questions, so check the description below. Now, if you think I'm on something, I'd especially appreciate that type of feedback, so please write in the comments. Subscribe for more contents. Check out my statistics playlist for more videos. And thanks for watching. Bye.